Welcome to today's episode. In this episode, we will introduce you to AWS IAM, which is a service provided by Amazon Web Services for secure access management of your AWS resources. With AWS IAM, you can create and manage users, groups, and roles, assign permissions, and set up multi-factor authentication to enhance security. By the end of this episode, you'll have a better understanding of AWS IAM and its benefits for your cloud infrastructure. Let's explore the world of AWS IAM together. Alright, so imagine you are in high school and there's this super exclusive club called AWS, short for Amazon Web Services. It's like the popular table in the cafeteria where all the cool computer stuff happens. Now, you can't just waltz in and start messing with everyone's projects and files, right? That's where IAM users come into play. It's like your school ID, but for this computer club. So let's say you have joined the AWS club. The club president, who's kind of like the root user, has access to everything. He can change rules, kick people out, or let them in. Basically, the top dog. But you get an IAM user, which is a sort of like your initiation name tag. On this name tag, you have some permissions, kind of like how your school ID has a barcode that lets you check out library books, but won't let you into the teacher's lounge. These permissions are listed in something called a policy document. Don't freak out, it's not as complicated as it sounds. Think of it like a rule sheet you get when you join a club. It's a list that says what you can do and what you can't. Like maybe you can upload pictures for the club's website, but you definitely can't delete stuff. We will talk about this more in the upcoming sections. Oh, and the whole logging in thing? You get what's called credentials. These are basically your super secret codes. You'll get an access key ID and a secret access key. It's like having a username and a super secret password that you should never ever share, kind of like how you wouldn't give out your locker combo. But what if you and your friends all want to work on the same project? You can be lumped into what's called an IAM group. It's like being in a group chat where everyone has the same permissions. You can all work on the same stuff, but still have your own name tags and secret codes. We're going to talk more about IAM groups in the next section. So yeah, IAM users and credentials are pretty much the keys to the kingdom, or at least to the AWS club. They make sure you can only get to the stuff you're supposed to, keeping everything chill and secure. The example command shows you how you can create a user using the AWS shell. Everyone in AWS has a special name tag known as an IAM user. It's like your backstage pass, showing which areas you can go into and which ones are off limits. But managing each individual name tag can be a pain, especially if there are tons of members. Enter IAM groups. These are like easy buttons for making life simpler. Let's say you and your buddies are all working on web development. Instead of giving each of you a personalized list of permissions, which would be super tedious, the club president can just create an IAM group called Web Dev Squad or something. Then whatever permissions this group has, you guys have it too. It's like saying, hey, you're part of Web Dev Squad, so you all get access to the same tools and areas. When the president makes this IAM group, they write up something called a policy document. Think of it as a club charter, but way less boring. It lays out what you can and can't do, like whether you can upload files to a specific part of AWS or if you can launch new virtual machines. Now, here's where it gets cool. If the club decides that the Web Dev Squad should also get into data analysis or something, the president can update the IAM group's permissions. Boom! Instantly, everyone in the group gets those new permissions without having to change each name tag one by one. So IAM groups are pretty much the secret sauce for making AWS manageable and less chaotic. They help keep everything organized so that the club, or I mean the AWS environment, runs smoothly. It's like the ultimate team play strategy for the cloud computing game. The example command shows you how to create an IAM group. So let's dive deeper into IAM policies in AWS. Those digital rule books that say who can do what in our techie AWS club. There are managed and inline policies. Managed policies are pre-configured by AWS or custom-made by you, which can be attached to multiple users, groups, or roles. Inline policies are created specifically for a single user, group, or role and managed within that entity. A policy isn't just a block of text. It's got different parts that make it tech. Think of it as your typical high school essay. It's got a structure to follow. First up is the version. It's like stating which edition of the school rulebook we're using. This ensures everyone is on the same page, literally. Next is the statement, the real meat of the policy. Imagine your policy is a list of class rules. Each statement is like a separate rule. No phones in class, raise your hand to speak, that sort of thing. Statements have different parts too. Effect is super straightforward. It's either allow or deny, saying if you can or can't do something. Action is what you're allowed or denied to do. It's like saying you're allowed to use calculators during math, but not during English. Resource is where you can do the action. Think of it as saying you can use calculators in room 201, but not in the gym. And sometimes there's conditions, which is like an only if part. For example, you can use the calculator only if it's a test day. It adds another layer of rules on top. So when you or anyone else in the AWS club tries to do something, AWS checks these policies like a hall monitor checking your hall pass. It looks at the effect, the action, and the resource and any conditions to decide if you're allowed to proceed. And there you go. Now you get how IAM policies work in AWS and what their parts are. They might seem complicated at first, but once you break it down, it's just another set of rules to keep our club organized and secure. The example JSON shows how to write a JSON policy that allows a role to list an S3 bucket. We've talked about IAM groups, users, and policies. Those are like your name tags and rule books. But what about IAM roles? Think of these as temporary costumes you can put on to do special tasks. Pretty neat, huh? There are a few types of IAM roles to know about. First, you've got service roles, which are like uniforms AWS services wear to interact with each other. Say, for example, AWS S3 storage service needs to talk to a database service. It puts on a service role to do that safely. Then there is the cross-account role. Imagine you've got a friend at another school and they invite you to their drama club for a day. You're not a member, but they give you a temporary badge so you can join in. That's basically what a cross-account role is. It lets resources from one AWS account access stuff in another account. Last up, we have instance roles. These are like special permissions you can slap onto virtual machines. So you've got a virtual computer running in AWS. You can give it an instance role to let it access other AWS services without needing to mess with user credentials. Now let's talk assume role. This is like the act of putting on one of those special costumes. When you assume a role, you temporarily get the permissions that role has. Like if you're in the chess club but you want to help out with a drama club performance, you can assume the role of a drama club member for a day, getting access to their props, scripts, whatever. Here's how it works. You can call the assume role API command and then you get a set of temporary credentials. These last for a short time and let you act as the role. It's like borrowing a friend's jacket. You wear it for a bit, then give it back when you're done. So in a nutshell, IAM roles are flexible temporary passes for doing specific tasks in AWS. They come in different types for different needs, and assuming a role is like temporarily stepping into someone else's shoes to get stuff done. The example command shows how our previously created role can assume into another policy document. You've got IAM users, roles, policies, the works. But wait, there's more. Now we're getting into identity providers, which are like the gatekeepers to our AWS club. It's as if we're adding a special entrance for VIPs and we want to make sure that only legit people can get through. Here's how it works. AWS has different types of identity providers or IDPs for short. SAML-based IDPs. Think of these like as your student IDs that work across multiple campuses. If your school is a part of a bigger network, your ID can get you into any school within that network. SAML is kind of like it lets you use one set of credentials to access multiple services, including AWS. Web identity providers. Ever joined a club using your Facebook or Google account instead of filling out a whole new form? That's basically what web identity providers do. They let you log into AWS using identities from other online services. OpenID Connect providers. This is a bit more advanced, but think of it like a customizable student ID. Maybe you've got a side hustle or another project outside of AWS. OpenID Connect lets you bring those credentials into AWS. AWS Cognito. Imagine a multi-club pass that not only lets you into AWS, but also into a bunch of other related clubs. That's Cognito. It helps manage identities across different AWS services and even non-AWS stuff. So we're back into the AWS club, and today we're diving into the VIP section. Multifactor Authentication, MFA. You know, it's that extra layer of security like a secret handshake for club members. But did you know that there are different MFA devices you can use? Yep, it's not a one-size-fits-all. Let's break it down. Virtual MFA devices. It's like an app on your phone that spits out random codes. Ever use Google Authenticator or Authy? Those are virtual MFA devices. To set it up, you go into the AWS Management Console, find the IAM section, and hit Manage MFA. You'll scan a QR code with your app, enter a couple of codes, and you're good to go. U2F security keys. Think of these as special USB sticks. When you're logging in, you plug it into your computer and it does this second check for you. Setting it up is a bit like installing a new game. Plug it in, go to Manage MFA, and in the IAM console and follow the steps to register the key. Hardware MFA devices. These are like old school calculators that show you a number you have to type in. They are standalone gadgets separate from your phone or computer. For setup, you'll go to Manage MFA, pick the hardware option, and enter device's serial number and some initial codes. SMS text message. This is the simplest. When you log in, AWS sends a code to your phone via text. You punch that in and you're in. Just add your phone number in the Manage MFA section and you'll get a text to confirm. Alright, so why does any of this matter? Well, each type has its pros and cons, right? Virtual devices are convenient but depend on your phone. U2F keys are super secure but can be easy to lose. Hardware devices are rock solid but kinda clunky. SMS is easy but not as secure if someone can hijack your phone number. So when you're choosing, it's like picking your character in a video game. Each has its own skills and weaknesses, but all of them make your AWS account a whole lot tougher to crack. It's like choosing whether to add laser beams or a moat filled with sharks or an army of robot guards to your AWS castle. MFA is your extra layer of security, the balancer that makes sure you're really you. So choose your MFA device wisely, set it up, and enjoy that VIP AWS experience. And that's all for this episode, folks. If you think this was helpful, please don't forget to like and smash the subscribe button for more interesting episodes. Until next time.